what it would be. But the first two would be 0.
Yeah, that's right.
Okay.
Yeah. I think. Wait, I think. Hugh, you only missed. I just started recording. You only missed like 2 minutes of questions. The rest of it will be recorded. No, if x3 is free, that doesn't imply that x1 and x2 are 0. It implies that x1 and x2 depend on x3.
Okay.
Right? So it would be like this. We would see zeros here and here, but there's no guarantees to be zeros here. That could be those numbers.
No. What I mean is like we're taking with our x, like our x vector that we're finding. This is A, right? And
Yep.
X is independent completely.
Yep.
If we're finding what the value of x is. Wouldn't the first two entries on that vector be 0, and then x3 or whatever it would be, the third entry would be a constant that's not 0.
Only if the last vector is the 0 vector.
Okay.
Because in this case, right, x1 equals 7x3, x2 equals negative 5x3, and x3 equals x3. So one solution would be when x3 equals 1 or 7 negative 5, 1. So this would be 7 times the first vector minus 5 times the second vector plus the third vector equals the 0 vector.
Okay.
So it doesn't imply any zeros necessarily.
Okay.
Okay, all right, let's do this. I want to just start with a really easy kind. We're going to do number 1. Number 1 is always an easy problem. Okay, so there's 3 vectors here. There's 5, 0, 0. There's 7, 2, negative 6. Yeah, I'm just going to make the homework based off of how much we get done. Like, obviously, homework problems aren't going to be ones we did in class, but I only want to give you 5 problems or 6 problems or something. Okay, so this is a set. So are any of you in the room willing to walk me through this? The question is, how do we determine if it's independent or dependent?
Create an augmented matrix.
Okay.
And then graph it.
Augment with what?
0, 0.
Okay, do we need to do that? We don't have to augment, do we? Right? We can just write a matrix. So we can just make a matrix. Then reref. And then check for pivots.
So you're looking for whether if it's independent or not.
Yes. So, okay, so pivots. Do we want there to be a pivot in every row or a pivot in every column? We want every column now, right? Because we want no free variables, because we want no more solutions than the trivial solution. Okay? Okay, so let's do it. Okay, RREF. We don't need to augment it, no need to. You can if you want, there's no harm in doing that. No difference. Okay, here we go.
Difference because it equals 0.
Because yeah, you're just gonna have zeros over there anyway. If you like that, if you like seeing that as confirmation that you're solving x equals 0, that's cool. Okay, so we get the identity. So pivot in every column, pivot in every row means 2 things: linearly independent and spans all of R3. And those always hang together when it's a square matrix, right? Because how could you have a pivot in every row and not every column if it's a square matrix? Okay, so this case gets us 3 pivots. So we have linearly independent. We have a pivot in every column. Okay, I want to look at 3. I'm skipping 2 because it's the same thinking. I want to look at 3 because it's easier, and I want you guys to save yourself time by thinking instead of just doing. Okay, 2 vectors now. 2 vectors in R2. Now I want to take someone from online. Nobody in the room talk. Okay, someone online, unmute yourself and tell me what you observe about these 2 vectors.
Scalar multiples.
They're multiples, right? Don't you notice that V2 equals -3 times V1? As soon as you notice that, this means, oh, hey, we have a solution to AX equals 0, don't we? The solution is the vector 3, 1, right? If A is 1, -3, -3, 9, which it is, A is made up of the columns. 3, 1 are the scalars that we put on V1 and V2 to reach the 0 vector. So our conclusion is this is linearly dependent. Now, I even showed more work than I really want you to show. If I put this on a test, I'd want you to just very quickly say, linearly dependent because they're scalar multiples of each other. That's as quick as you could be. Okay. All right, somebody else from online. Let's do the, I want you to do the intuitive ones, 15 through 20. They don't require any work to be shown. That's why I like them. Okay. And then, so we'll take 6 people from online, and then we're going to stop, and I'm going to assign problems to groups. Okay. So 15 gives you the vectors 5, 1, 2, 8, 1, 3, and -1, 7. So I'll just take a volunteer. I don't want to pick on someone if they don't know. Is this independent or dependent?
Are you asking the online people?
No, just them. Yeah, you guys just sit and think for a
I
second.
think it's dependent because there are 2 free columns. So we can definitely write 2 of the vectors in linear combination of the other vectors. That's why it's linearly dependent.
Okay. Okay. Did you ref it to figure that out?
No, it's just simply the fact that there are 4 vectors and we're only in R2 shows that it's linearly dependent.
That's the key. I'd want you to immediately say dependent because 4 vectors in R3. Wonderful. Our theorem says if there's ever more vectors than the space you're in, I lied, we're not in R3. We're in R2. There's 4 vectors in R2. Of course, they're linearly dependent. There's no way to get, there's not going to be any way to get a pivot in every column if you put that in a matrix. Okay, 16.
It was the most you can get.
That's right. The most pivots you could get is 2. All right, here's the 2 vectors in 16. 4, -2, 6, and 6, -3, 9. All right, I'll just call on somebody if that's okay. Christina, what do you think? Dependent or independent?
I think it's dependent
Tell me why.
because they're scalar multiples.
Good job. Because they're scalar multiples. Good. So they would only span a line, right? You're not getting like a new dimension for each vector. Good job. Okay, 17. I'm not even going to write 17 down. Oh, I have to, I guess. You all don't have books out, do you? 3, 5, -1, 0, 0, 0, and -6, 5, 4. Okay, somebody in the room, go ahead. No. Dependent because of the 0 vector. The 0 vector is a member of the set. It's automatically dependent. Good. Okay, the next 3 are just like it, so I don't think I need to write it out. 18 has 4 vectors in R2, so it's dependent, right? Dependent because 4 vectors in R2. 19. Let's see, there's 2 vectors in R3. Let's check if they're scalar multiples or not. No, they're not. So it's independent because the 2 vectors are not scalar multiples. And finally, 20 contains the 0 vector, so dependent. Dependent because contains the 0 vector.
See the problem.
Yeah, I know you can't see them. They're the same setup as what we have above. Okay, yeah, so
I
the-
wasn't sure if you-
Yeah, you don't need to write them down.
So if there are less vectors than entries, it can still be independent, but it won't span like the entire.
Beautifully said. If there are fewer vectors than entries, it can still be independent, but it won't span the entire vector space. Well said. Like
It's like the reverse. It's like 2 vectors in R4,
2 vectors in R4 could be independent.
but it just won't span because there's only 2 vectors.
Won't span all of R4. We don't have enough vectors. Good. Okay. All right. I'm going to put you in groups of 3, and I'm going to put Zoom people with Zoom people, and you guys will just need to keep your distance but talk. Okay. Make sense? All right. So I'm going to put you in breakout rooms. You're going to you're gonna write up 2 problems. I'll come to your room and tell you what problems you're gonna do. You're gonna write up 2 problems on a Jamboard, share it with me, and be prepared to explain your solution to the class, okay? So it's gonna be, we do groups of 3 or 2, it's easier.
3, 3, 2, 2.
Yeah, no one really uses these markers, so I guess you could. That would be fine. Can I tell them how? What? No. So let's have you 2 work together, okay? And you 2 work together, okay? And you 2 are gonna work together, and you 2 will be together, and you 2 will be together, okay? And if you wanna be on the board, you can, and if you wanna be on your Chromebook, that's fine. Again. Sorry, Hugh, I didn't start the recording right away, but it's going now. Okay, let's go to the back. Let's take this one. So 27, 31, and 32. So if you guys have books out at home, could you look at 27, 31, and 32? All right, and I'm gonna show the work here. And
So 27 asks if you have a 5 by, I'm forgetting what was the.
I think it was 5 by 7.
7 by 5.
Oh.
So we have a 7 by 5 matrix, and we want to make sure that the matrix is linearly independent. How many columns must be pivot columns? And we said that you need to have 1 pivot per column, so you need to have 5 pivots.
Good.
Then 31 asks, it gives you a matrix and that, wait, let me just,
No, it's okay. Yeah.
It gives you a matrix, and then it asks you to, it tells you right away that it's not linearly independent. It tells you that it's linearly dependent and that V3 is the sum of V1 and V2. And then it's asking you to come up with some vector that describes a combination of these 3 vectors to make it a solution to AX equals 0.
yeah, so since we know that the first 2 columns sum to equal the 3rd column, we know that the first 2 added subtracted by the 3rd one equals the 0 vector. So yeah, finding a solution for where AX equals 0, we just put 1 in front of V1, 1 in front of V2, and then -1 in front of V3. Yeah, so it's the vector 1, 1, -1.
Yeah, so it's what they're telling us is that this thing is true. Yeah, we don't know. There we go. We don't really know. Do we know what A is? Is it given? Yeah, it is. Okay, so A is given, but when A gets multiplied by this vector 1, 1, -1, it gets us the 0 vector. What this is doing is it's verbally giving us a linear dependence relation and then showing that this is a non-trivial solution of AX equals 0. And every relation among the columns represents one of these non-trivial solutions. And then 32 is the
32 is
same.
the
Right?
exact same thing, just different, a different relationship.
Yeah. You don't have to explain
Yeah.
it. That's good. So 32 is the same problem, but with a different relationship among the columns. So they did the same deal. Okay. Questions on either of those? Okay. You want to move?
Yeah.
Thanks. All right. So this is you and Sangbum, right?
Yeah.
Okay. Great. All right. So these guys did 14. I'll try my best to show this. Maybe better if I did this and then held it up. I don't know.
So pretty much
Okay,
the
go for
question
it.
gave us a set of 3 vectors. And as you can see in the 3rd vector, the last column or the last row is a variable h. And so the question asked to come up with a number for h that would make the set linearly dependent. So we pretty much did a bunch of elementary row operations since we can't do ref on the calculator with the variable. And at the end, we come up with this kind of final matrix where in the 3rd column, we want to make sure that it's a free variable, because otherwise if h minus 26 equals 1, then it would be a pivot, and that would make the set linearly independent. So in order for it to be a free variable, we set h minus 26 equal to 0. So if h equals 26, then the set is linearly dependent.
Good. And Sangbum, for some reason, did a bunch of wacky algebra just for fun. You can all see that there.
You got it wrong too.
Yeah. And then he made a mistake in the process. Okay. Good. Guys, got any questions? Okay, all right, 8.
So question 8 gave us that matrix and asked to determine if it was independent or dependent. So looking at it, you can tell that there are more rows or more columns than rows. So without roughing it, you already know there's going to be a free variable, which means that there's infinitely many solutions. So it's going to be linearly dependent.
Good job. Yeah, that's a case where there are more vectors than there are numbers in each vector, right? We've got 4 vectors, but there's only 3 numbers in each vector. So it's linearly dependent. Good. And then 21, they had true, false. So I don't really need to, they're going to explain it. If you have it in front of you, you want to explain through 21? Section 1.5.1.7. So go forward a few more pages. Okay, so Eric's going to explain that, and I'm standing within 6 feet of Eric, so I'm in trouble now. Administration walks in, I get fired.
It states the columns of matrix A are linearly independent if the equation AX equals 0 has the trivial solution, and that's false because the wording should be if it only has the trivial solution.
Yeah, good. Listen, it always has the trivial solution, right? If that's the only solution, then you have linear independence. Good, keep going.
And then B states if S is linearly dependent, if S is a linearly dependent set, then each vector is a linear combination of the other vector in S. That's not true because there can be 2 independent like vectors in a set, but the phrasing should be there is at least 1 vector in the set that is a linear combination of 2 others.
Yeah, good. Pause for 1 second. So he said that. So the statement said that every vector, right? Doesn't that what the thing says in B? Every vector is a linear combination of the others. And that's not.
Combination of the other vectors.
Yeah. So that's not true, right? They could be, but that's not guaranteed when it said it's linearly dependent. Eric said something that no one else has said yet that I want to make you aware of. Individual vectors are not dependent or independent. It's a whole set that's dependent or independent. Okay. So I'm trying to think of an example.
So with relation to each other, that's how you.
Right. So you can't say that like this vector is independent, but all of these are dependent. If you got a set, they're linearly dependent. You know, it's like dependence kind of wins. As soon as you have 2 that are, scalar multiples or linear combinations of each other, then you've got dependent.
Kind of like you have something in R3 and you have 3 vectors that are all in 1 plane, and then 1 vector that's perpendicular to the
Yes.
plane. 3 in the plane. That the set of those 3 are all dependent.
Yeah.
If you can't make a linear combination of the 4th one, but regardless,
The new set is still dependent, right?
set's still dependent.
If you have a set that's dependent and you add another vector that happens to pop out of that span, that the set is still dependent. Good. Okay, and then want to do the last 2?
The columns of any 4x5 matrix are linearly dependent. That's true because there are more vectors than entries. So at least one of the vectors has to be a linear combination of the other vectors in the set. If in the D states, if X and Y are linearly independent, and if X, Y, Z is linearly dependent, then Z is in the span of X, Y. This is true because X, Y are linearly independent, and if X, Y, Z is dependent, Z must be a linear combination of X and Y, and therefore it is in the span of X and Y.
Yeah, that's a hard one to wrap your head around. But the idea is that if you have a set that starts as linear, what is it? Starts as independent, and you add a vector, and the new set is dependent, and that new vector must be a linear combination of the others. Okay, good. And I've got, what, 2 minutes? So it's probably time to be done. Can I take a picture of this and we'll talk about it next time? Is that okay? All right. So I've got, yeah, you can erase it for me. That'd be great. Well, it is nice to have math on my board again. It feels like real school. Yeah. All right. So I'm going to take a picture of the work on the board, and I'm also going to keep all your Jamboards, and we'll talk about some of these next time. I'll post your homework right now. Okay. So I'll decide on a few problems I want done for homework, and I will see you on Wednesday. Bye, guys.
Thank you.
Thank you.